Hi folks, we're going to take a look at number 1 from the October 4th lesson. So here we've got $5,000. It's placed into an account at 5% interest compounded annually. Okay, and they want us to model this with a function. Okay, so just a reminder on how to do this. So we've got, let A be our final amount. And we start with our initial amount of $5,000. Okay, and say after the first year, you need to determine that amount plus 5%. So that's equivalent to multiplying that by 1.05. Okay, but then after the first year, because it's compounded annually, you multiply 1.05 to this new total, and then so on for future years. So we can model that by just taking the exponent n here. Okay, so first thing to notice, how is this different from the functions that we've been studying so far, is now we've got a variable in the exponent, okay, as opposed to the variable being in the base. And of course, this is an example of an exponential function, okay, and in particular, this is an example of exponential growth. Okay, so technically, if you're writing a model, we should be specifying that A is the final amount, and n is the number of years. Okay, now in the next one it says how much is going to be worth in 25 years. So no issue there. We just input, in this case here, 25 for n, and we calculate that, and we've got 5,000 times 1.05 exponent 25. And here we're going to estimate that here as $16,931.77. Okay. Now I ask a question here, and I say, why could this problem be solved without a calculator? Okay, because in principle here, when we look at this exponent of 25, well, we know how to deal with exponent 25. You just have to take 1.05 and multiply it by itself, and I guess we could do that by hand instead of using a calculator. So it's certainly possible to calculate the final answer by hand and not using a calculator. But of course, that's certainly not advisable, especially if you do have access to a calculator. Okay, and when we get to number 2, we'll see why this might not always be the case. Okay, so just a reminder here that an exponential function is one in which the exponent is variable as opposed to the base, and some of the types of questions that it can help to model are things like exponential growth and decay.